All right. Thursday, we talked about the sum and the difference formulas and how they could be used to find exact trigonometric values of angles that aren't multiples of 30 or 45 degrees. Those we have memorized. There are other formulas that can be used for that same purpose. Double angle formulas, half angle formulas, and power reducing formulas. And that's what's in 5.3. So let's just jump right in and start these 5.3 examples. I got another copy of the formulas that I can keep handy for these.
Hey, before we start 5.3, can we finish number 7 on 5.2?
I would not like to do that. Are you asking because you have done it yourself and want to check your answers, perhaps?
No, I just did the triangles and stuff like we had done. So maybe after class we could go over number 7.
Yeah, we could. I had drawn the triangles for you, and it is almost identical to number 6. You're just using the addition formula for cosine, the addition formula for sine, and the addition formula for tangent. So it's identical to 6. And actually, when I updated the notes, I took example 7 off of there because I didn't feel like we needed to do 2 that were identical. But we can if you need it, Chastity. That'd be fine.
Okay, yeah, I don't have to have it. That's fine since it's like 6.
Oh, yeah, it is. It is just like 6. Yeah, don't need to do 2 of those. Okay, so example or section 5.3, double angle, half angle, and power reducing formulas. The first one, we're given 2 triangles. One of the triangles has an angle theta marked, and one of them has an angle alpha marked. And we're supposed to find in number 1 the cosine of 2 theta. Remember, I'm going to give you all of the formulas that are at the top of the 525.3 note. All of these will be on the test. But the one we need for cosine 2 theta, actually there are 3 formulas that you could use for cosine 2 theta. Doesn't matter which one you use, you should get the same answer, obviously, for all 3 of those. It could matter if we were verifying an identity that had a double angle formula in it, but we don't have time to do those. So as far as getting a numeric value for cosine 2 theta, you could any, mini, miny, mo use either one of those. If we want to use, let's say the last one is 1 minus 2 cosine squared theta, then we could read the value of cosine theta right off this triangle. What would cosine theta be? Yeah, it would be 4/5. So cosine 2 theta would be 1 minus 2 times 4/5 squared. And you should be able to work that out with a calculator or without a calculator. That's 1 minus 4/5 squared is 16/25. Double that would be 32/25. Let me double check it. 4/5 squared is 16/25 times 2 is 32/25. So when you subtract, you get negative 7/25. We were using the last of these 3 formulas. We could use any one of those 3 formulas. I, any, mini, miny, mo. Wrote it down wrong. Yes. Y'all, you're not going to know until you have a 20-something-year-old daughter applying for a job how nerve-wracking this weekend has been. That's sine squared, not cosine squared. And so sine squared would have been 3/5 instead of 4/5. So squared would be 9/25. 2 times that would be 18/25. And so, that's funny. It just ends up being +7 instead of -7. 25ths. All right. The second one is the tangent of 2 alpha. So we're going to be using the other triangle, and the formula for tangent 2 alpha is 2 tangent alpha times 1 minus tangent squared alpha. So make sure you're looking at the angle alpha, not the angle theta. What is tangent alpha? That's a 7. Yeah, it's 7/24. So 2 times 7/24 over 1 minus 7/24 squared. And I've already calculated that. I'm just going to tell you what I got. 336 over 527. You had to write down some middle steps, it would be okay. These two sections are pretty easy. Just because you're given a formula, all you have to do is extract the values you need from what's given and substitute into those formulas. Number 3, one more. This one's a tiny bit different. You can tell that it has to do with a half angle formula instead of a double angle formula because it involves sine of theta over 2 and cosine of theta over 2. Actually, if we just call this ugly, and we call this my second favorite variable, ugly. Let me take back what I said about definitely a half angle formula. Look at all your double angle formulas and your half angle formulas and see if you can see one that involves 2 sine of ugly cosine of, excuse me. Oh, you know what? That's the same old ugly. That's not a different ugly. Look for a formula that has 2 sine u cosine u, or 2 sine something cosine something. Is that a double angle formula or a half angle formula? It's actually this formula. It's 2 sine ugly cosine ugly. So we just need to put this back together. This is sine of 2 uglies, and in place of our ugly, we're just putting theta over 2 because that's what ugly is here. The sine of 2 ugly is 2 sine ugly cosine ugly. So we need to flip that back over and see what sine of, actually, I can simplify that. That's just sine of theta because the 2's cancel. So flipping the paper back over, what is the sine of theta? We have to have the hypotenuse for that. And the Pythagorean theorem would be the square root of 24 squared plus 7 squared. I just happen to remember that 7, 24, 25 is a Pythagorean again, or a Pythagorean triple, sorry. Actually, we're using theta. We don't need that for alpha. We need sine of theta, which would be 3/5. I'm writing on too many different papers. Yeah, that's right. The next three examples, we're not given the triangle drawn, but we can draw a triangle. We can draw a triangle whose cotangent is 3, and the angle is in the third quadrant, and then we can find whatever we're asked to find. So like I did on a lot of the problems last night, I just need to draw a third quadrant angle, call it theta, and label it in such a way that its cotangent is 3. If its cotangent is 3, what does that mean tangent theta is?
One-third.
Yeah, if cotangent's 3, then tangent's 1/3, and tangent is opposite over adjacent. So that's how, excuse me, how I need to label my triangle. The side opposite theta is 1, the side adjacent to theta is 3. But what's important to remember right here? Yes, quadrant 3, both my X and my Y are negative. So this is -1 and -3. That's all I need to find the sine of 2 theta, cosine of 2 theta, and tangent 2 theta. Remember, the reason we're doing this is I can't tell you exactly the angle whose cotangent is 3. I don't know exactly what that angle is, but I don't even have to know what that angle is to find these 3 things, sine 2 theta, because I have a formula for it. Sine of 2 theta is 2 sine theta cosine theta. That's actually the only one of the double angle formulas that I use often enough to remember it. I have that one memorized. The rest of them I just look up when I need them. So sine of theta would be, oh, we need the hypotenuse here. What would the hypotenuse be? Yeah, square root of leg squared plus leg squared, the square root of 10. So sine of theta would be -1 over square root of 10. And cosine of theta would be -3 over square root of 10. When I multiply a positive times a negative times a negative, I'm going to get a positive. 2 times 3 is 6. Square root of 10 times square root of 10 is just 10. And 6/10 reduces to 3/5. So without knowing exactly what theta is, I know the sine of 2 theta is 3/5. All right, what about cosine of 2 theta? Again, I have 3 choices of formulas that I could use for the double angle formula for cosine. If we want to use the same one we used last time and make sure I copy it down right this time, it's 1 minus 2 times sine squared theta. So we already have sine of theta is -1 over square root of 10. Make sure we square that. 1 minus 2 sine theta squared. That would be 1 plus, actually, tell me why it wouldn't be plus. You see why it's going to be 1 minus? Right, you do exponents before multiplication. So -1 over square root of 10 squared is +1 over 10. And then times -2 is 2/10 or -1/5. And I'm hoping that y'all are working on being able to work with fractions comfortably without having to grab the calculator, but I certainly don't want you to miss it on the test. So there's not going to be any part of this test that you can't use the calculator on. All right, what about tangent 2 theta? I have a formula for that. Or is there an easier way to get tangent 2 theta? Yeah, if I already know sine and cosine, then I'll just say tangent 2 theta is sine 2 theta over cosine 2 theta, which would be 3/5 divided by 4/5, or just 3/4. Pretty easy. Let's talk about the half angle formulas for a minute. I need to show you something on those. You'll notice that sine of alpha over 2 and cosine of alpha over 2, and actually tangent of alpha over 2 as well, all three of those formulas have a positive or negative in them. Well, sine of something can't have two answers. So I've got to have a way of figuring out whether to use the positive square root or the negative square root. That's going to depend on in which quadrant alpha over 2 lies. However, I'm not given the quadrant that alpha over 2 is in. I'm given the quadrant that alpha's in. I'm going to have to figure out if alpha's between pi over 2 and pi, then where is alpha over 2? Which quadrant is pi over 2 to pi? That is the second quadrant. So would alpha over 2 be in the same quadrant? What if alpha is between pi over 2 and pi? What does alpha over 2 have to be between? No. This is just a compound inequality. And I know how to solve a compound inequality. I can multiply something times all three sides or divide all three sides by something. If I divide all three sides by 2, then the middle will be alpha over 2. What will the left be? Yeah, pi over 4. I'm just dividing pi over 2 by 2. And the right-hand side divided by 2 is just pi over 2. So if alpha is in quadrant 2, then alpha over 2 is going to be in quadrant 1. Now, you always need to solve this inequality. You can't just assume if alpha is in quadrant 4 and alpha over 2 is going to be in quadrant 2. That's not always true. So make sure when you're given the parameters for alpha, you divide all three sides by 2 to get the restrictions on alpha over 2. And when we use the formula for sine and cosine of alpha over 2, we're going to remember that in quadrant 1, both the x and the y are positive. So when we use these two formulas, we're going to use the positive square root rather than the negative square root. That's how you determine whether to use the plus or the minus. See where alpha over 2 is. For sine of alpha over 2, we'll use 1 minus cosine alpha. This is not alpha over 2 under the radical. It's just 1 minus cosine alpha over 2. And when we get to the next part, it's 1 plus cosine alpha over 2. Since I don't have memorized on the unit circle, any angle whose secant is -3, I need to draw a triangle in quadrant 2. We're going to draw alpha, not alpha over 2. I need to draw alpha in the second quadrant. Here's my second quadrant alpha. And label it in such a way that its secant is -3. Now, my brain doesn't think secant as well as it thinks cosine. So I just changed that to if secant alpha is -3, then cosine alpha is -1/3. And in terms of opposite, adjacent, and hypotenuse, which two sides does that give me? Gives me adjacent and hypotenuse. So adjacent to alpha is 1, hypotenuse is 3. Where does that negative go? It's in the second quadrant, so your adjacent would be negative, your opposite would be positive, or your x would be negative, your y would be positive. What would this other leg be? Is it square root of 10 or square root of 8? When I'm missing a leg of a right triangle, I say square root of hypotenuse squared minus leg squared. 9 minus 1 is 8. So that's square root of 8. Now I could write it as 2 square root of 2. I'm not going to yet, and I think you'll see why. In the formula for sine alpha over 2, I've already decided to use the positive square root. I need 1 minus cosine alpha. Actually, I didn't even need to draw the triangle on that one because I already knew that cosine alpha is -1/3. If secant's -3, then cosine's -1/3. Yeah, I didn't even need that other leg. 1 minus -1/3 over 2. Now this is just going to end up to be an ugly answer. Sometimes you can't get an exact answer that's pretty. 1 minus -1/3 is 1 plus 1/3, which is 4/3 divided by 2 is 2/3. Actually, that's not as ugly as I thought it was going to be. Let me just double check something. 1 3/3 plus 1/3 is 4/3 divided by 2 is 2/3. Yeah, that didn't turn out as ugly as I thought it was going to be. Since on the test I have written, you don't have to rationalize the denominator. You could leave that square root of 2/3. That's okay with the test. My math lab, you're probably going to have to say square root of 2 over square root of 3. And then rationalize it. Square root of 6 over 3. All right. Cosine alpha over 2 would be square root of 1 plus cosine alpha. Cosine alpha is -1/3. One plus -1/3 is 2/3. Take half of that, And you get 1/3. That would be okay with me on the test. But in my math lab, you're probably going to have to rationalize it. And you'll get square root of 3 over 3. And for tangent alpha over 2, we could use a half angle formula for tangent, but it would be easier to say tangent of sine alpha over 2, excuse me, tangent of alpha over 2 is sine of alpha over 2 divided by cosine alpha over 2. And it's actually easier to use the unsimplified or unrationalized form of sine and cosine. If I leave sine of cosine as 2 over square root of 2 over square root of 3, and write cosine as just 1 over square root of 3, I can see that when I flip the divisor, my square root of 3s are going to cancel. Just get square root of 2. Any questions? Now, a common mistake on the test is to forget how to figure out whether to use the plus or minus each time we use a half angle formula. It just so happens in this problem that if you had forgot about there being a plus or minus and you just use the plus, you'd get the right answer, because alpha over 2 was in the first quadrant where both your x and the y are positive. But I don't think that'll be the case on number 6, which is why I picked another one of those. Tangent alpha is 8/15, and alpha is between 180 degrees and 270 degrees. What quadrant is that? That's the third quadrant. And I can draw a third quadrant angle. Again, we're drawing alpha. We're not drawing alpha over 2. We're drawing alpha and labeling it in such a way that tangent of alpha is 8/15. Which two sides does that give me? 8 is opposite and 15 is adjacent. My triangles are never to scale. It certainly doesn't look like the adjacent side is almost twice as long as the opposite side. And also pay attention to the fact that this is in quadrant 3, where we know what? Both the x and the y are negative. So that needs to be -8 and -15. Now, we use that information to draw our triangle, but when we use the formula, we've got to figure out which quadrant alpha over 2 is in. If alpha is between 180 and 270 degrees, what's alpha over 2 between? I'm just going to leave it degrees. Since this was in degrees, I'm going to leave it 90 to 135. And what quadrant's that in? Between 90 and 135 degrees, that's quadrant 2, where my x's are negative, but my y's are positive. So when we find sine of alpha over 2, are we going to use the negative or the positive square root? Told me alpha over 2 is going to be in the second quadrant. So in the second quadrant, is sine going to be positive or negative? Sine's going to be positive. What about cosine in the second quadrant? Are we going to use the positive or the negative square root? Alpha over 2 is in the second quadrant, and in the second quadrant, your x's are negative, so your cosines are negative. All right, same formula as before. The sine of alpha over 2 is, we've already decided to use the positive square root of 1 minus cosine alpha over 2. And for cosine alpha over 2, we need 1 plus cosine alpha divided by 2. What's cosine alpha? Well, we need the hypotenuse for that. Square root of 225 plus 64 is 289. Is that a 17, I think? 8, 15, 17 is a Pythagorean triple. So now tell me what cosine of alpha is. Negative 15 over 17. 1 minus negative 15 over 17 divided by 2. And cosine will be 1 plus negative 15 over 17 divided by 2. In this first formula, minus a negative is a positive. This is 17/17 plus 15/17 is 32/17 divided by 2 is 16/17. Let me double check that. 17/17 plus 15/17 is 32/17 divided by 2 is 16/17. It would be fine with me if you left that 4 over square root of 17 on the test. My math lab's going to call it 4 square root of 17 over 17. All right, cosine alpha over 2 would be 17/17 minus 15/17 is 2/17 divided by 2 is square root of 1/17, or just 1 over square root of 17. If you rationalize that, it's square root of 17 over 17. Lost my negative. Watch out for that. Since alpha over 2 is in the second quadrant, all of those should be negative. And then for tangent alpha over 2, we'll just use sine of alpha over 2 divided by cosine of alpha over 2. And again, it's easier to use the form that we haven't rationalized, because I can tell if I put sine over cosine, the square root of 17s are going to cancel. Tangent of alpha over 2 is just going to be negative 4. Any questions? The next three, there are different ways that we could come up with these exact trigonometric values, possibly by using addition or a subtraction formula. I'm not going to tell you on the test which of the groups of formulas you have to use to find these exact values. We might say tangent of 3/8 pi is, let's see, 3/8 would be 1/8. We don't have 1/8 memorized though. We might think of two formulas that subtract to give us 3/8 pi. Because these three formulas, or because these three problems tell me specifically to use the half angle formula, that's what I'll do. And number 7, I have to think, what is 22.5 half of? No, I'm not asking what's half of 22.5. I'm asking what is 22.5 half of?
45.
Yeah, it's half of 45. So I can write that as cosine of 45 degrees divided by 2. This is my half angle. So that means 45 degrees is my whole angle. And when I use the half angle formula for cosine, half angle formula for cosine, am I going to use the positive square root or the negative square root? Remember, I'm looking for the cosine of 22.5 degrees. Is that going to be positive or negative? (22.5 degrees is in the first quadrant, and in the first quadrant, cosine's positive. So I'm going to use the formula positive square root of 1 minus, no, cosine's 1 plus cosine of my angle. My angle here is 45 degrees. I think it might have helped you just a little bit if I had used alpha here and here, because that's what's in the formula, alpha. 22.5 degrees is alpha over 2. Alpha is 45 degrees. So the formula is 1 plus cosine alpha divided by 2. And what is cosine of 45 degrees? This is the one that's going to come out terribly ugly. 1 plus square root of 2 over 2 divided by 2. Now, I do want you to clean it up a little bit. I don't want you to leave a fraction, a complex fraction under a radical. That's just too ugly. What can I do to clean up this complex fraction, to clear out this baby fraction within the big fraction? How do I clean up complex fractions? You multiply both the numerator and denominator by the common denominator of all the baby fractions. This only has one baby fraction. Its denominator is 2. So I'm going to multiply the whole fraction by 2 over 2. I'm going to be sure to distribute this 2 completely in the numerator. So I'll have the square root of 2 times 1 is 2. 2 times square root of 2 over 2 is the square root of 2. And in the denominator, 2 times 2 is 4. And there's just one more thing I want you to do because it's easy to do. If you separate that square root of a fraction into square root of the numerator and square root of the denominator, that becomes a rational denominator. Square root of 4 is just 2. So I know if you were checking your answers in the back of the book, I know how it would be written. Instead of having 2 in the denominator, you could just write the coefficient as a half. That's how it would be written in the back of the book. My math lab should take either that 1/2 coefficient pulled out front or this whole thing still over 2. It should take either one of those as correct. You understand what I'm saying about that? Either 1/2 out front or 2 in the denominator. Either one should be okay. All right, number 8. Again, I may be able to think of 2 angles that I have memorized that either add or subtract to give me 105 degrees. If that's the case, I could use an addition or subtraction formula. But on the test, I'm not going to tell you which group of formulas to use. This says use half angle formula. So I need to think 105 degrees is half of what? You're still giving me half of 105. And yeah, it's half of 210. The 105 is my half alpha. So the 210 is my alpha. Now, what quadrant is 105 degrees in? That's in the second quadrant. So when I use my formula for the half angle formula for sine right here, am I going to use the positive or negative square root? I'm looking for sine of 105 degrees, which is in the second quadrant. And in the second quadrant, sine is positive. Make sure you understand your sine in front of the radical is coming from the 105 degrees, not the 210 degrees. You're looking for the value of sine of 105 degrees. So the sine of 105 degrees has to be positive. And then you'd have 1 minus cosine of 210 degrees divided by 2. And what's the cosine of 210 degrees? Is that closer to the x-axis or to the y-axis? 210 degrees is just past 180 degrees. So is it my x or my y that's close to -1 here? My x was -1 here. It's still almost -1 there. So cosine of 210 degrees is square root of 3, negative square root of 3 over 2. Whole thing's divided by 2. And that's just ugly. I'm going to go ahead and put my 2/2 under the radical to rational or to clean up that complex fraction. When I multiply that complex fraction by 2/2, I have square root of 2 times 1 is 2, minus a negative is a positive. Square root of 3/2 times 2 is just square root of 3. And in the denominator, 2 times 2 is 4. So just like I did on the previous problem, I can either leave a 2 in the denominator after I break up the radical, or I can just bring 1/2 out front as a coefficient. Either way, it's still pretty ugly answer. All right. Oh shoot, we have 4 minutes left. Let me just do this for you. What is 3/8 half of? 3/8 is half of 6/8. That's right. And what is 6/8 reduced to? Yeah. This is tangent of 3 pi over 4 divided by 2. Just like we said, 105 is half of 210. We need to say 3/8 is half of 3/4, and then just use that formula. Well, we don't even have time to start talking about the last kind of problem is using the power reducing formulas. If y'all will give me just a minute before you start the homework, I will go in and take those problems out of the homework. I already had decided I was not going to put one on the test. So I'm going to say we don't have time to cover those and take it out of the homework. Homework will be available in just a jiffy. All right. Any questions about the double angle or half angle formulas? All right. I'll see y'all tomorrow. Have a good day. Dominic, you need to ask me anything?
Yes, I
Yes, sir.
did the day 3 homework yesterday. Is it possible I can turn it in today for a late grade?
Sure. Why did I think I had that for you already?
I think I saw it as a 0 in Pearson.
Oh, I remember. Yes, go ahead and send that to me. Just send me a picture of it and
Okay,
I'll change that grade for you.
and I got one quick question on one of them. I think it was, let me see if I can find it, 47. I got to a point, I'll just read what I got to at the very end. And I saw that it was similar, but I couldn't figure out how to get the answer there. I ended up getting, if this sounds right, I'll just read the beginning question if I can find that paper I had.
Could you, let me think. Are you using your laptop for Zoom right now?
Yes,
Hold your paper up to the camera and see if I can read it that way.
my, which part, the beginning or the end?
The beginning, I need to see what the problem is. I have no idea. I'm gonna
They're
go ahead
good?
and stop record.